In this, we'll see the designing of a virtual private network. Basically, designing of the virtual private network is basically depending upon the organizational needs and goals. What type of business they use, how many employees they have, infrastructure already placed in place, security requirements. Based on this, this VPN design will be taken place. And VPN design is the most difficult aspect of the design process. That is called enforcing security, and client-side VPN tunnels creation, establishment is the most difficult process. So business models with which you can come to know the whether you require a site-to-site or client-to-site or site to remote access. So these are three models we have seen previously. That is site-to-site means organization to organization, or between the branches of a same organization, and client-to-site in the sense maybe an employee of an organization may be connecting to a branch office or maybe a main office, like that. So VPN can be classified as site-to-site or client-to-site, can offer cost-effective and secure connectivity. So these are the questions that need to be addressed before going for the designing of the VPNs. What does it do, and what products or services do it sell? Okay. Depending upon the cost of the products and depending upon the services, value of the services that they provide, these VPNs are used especially. The nature of the business, especially to secure the VPN design, that you should have the secure connectivity, availability, authentication, secure management, reliability, scalability, and performance. So here, scalability means any number of employees can be in a position to access this VPN, and reliability means at least there should be some backup plan for that. If anything was gone wrong and how to reroute, that is what the backup plan. Reliability. We'll see in the designing process how this can be achieved. So here, there are several ways to increase the VPN client, but there are some dedicated tunnels will be there, split tunnels will be there, redirected tunnels will be there. Like there, several other methods will be used here. But among all the methods, the split tunnel is easy, but is somewhat dangerous. The reason is it describes the multiple paths. One path goes to the VPN server and is secured. Another unauthorized and unsecured paths permit users to connect to the internet sometimes. So because of the multiple paths, and one may be secured and one may not be secured. So in such cases, it will go for the security branches sometimes, while still connected to the corporate virtual private network, but still the user will be in a position to connect to the internet from another route. Leaves the virtual private network server and internal LAN vulnerable to attack. So here is the example of showing the diagram that a remote user can unsecure, sometimes maybe connecting to the internet or web server in an unsecured manner, simultaneous connection to the internet via user's private ISP or other internet access methods. So the reason split tunneling opens a security risk in our networks. So what to do then? So we need to use some dedicated tunneling. So you can go to the TCP/IP settings of the Windows where you can disable this split tunneling. So only dedicated tunneling will be maintained. So you can go for preventing split tunneling like this. Planning VPN deployment, consider the existing infrastructure, whether the organization will be in a position to provide the finance for or make an allotment of the budget for making of the VPN or not. Otherwise, it is better to go for and using of the software VPNs instead of placing of the hardware VPNs. Decide on a placement of VPN servers, research hardware and software to use, develop the list of requirements, and follow the security policy guidelines. So the VPN topology, because the topology is very important. We all know that the star topology, ring topology, mesh topology, this kind of topologies in the computer networks we have seen. So in order to increase the reliability, the best topology is mesh topology. Mesh topology is so reliable. Even though one line fails, you can approach another computer through another line. So this VPN topology is a key point in designing the VPN. So how components in a network are connected physically to one another is to be looked after. Determine how gateways, networks, and other clients are related. corresponds to the basic physical and logical topologies of any network will be followed here. And one more thing is in this topology, along with this VPN routers, one more thing we need to look after is the firewalls. So without firewalls, this VPN also will not work. Okay, VPNs we cannot separate VPN and firewall. Okay, we have to place it together. So here the best thing is first thing is mesh topology, which is so reliable. So full mesh is a type of mesh arrangement, partial mesh and full mesh. So every subnet is connected to another subnet in the VPN and very complex to manage also. Partial mesh is any subnet in the VPN may or may not connected to another subnet. The diagram is like this. So here here are 4 subnets are there and VPN routers and are connected here. There is a dedicated tunnel will be there from between these routers. So this is the tunnel mode. By default, if you use IPsec for the VPN creation, they will work in the tunnel mode when you use these VPN routers. Star topology, also known as hub and spoke configuration. VPN gateway is the hub. Network that participate in the VPN are called as RIM subnetworks. Separates the SAS, that is security association, are made between the hubs for each RIM subnetwork in the star configuration. Central VPN routers is at organization central office. Any LAN on the computer that wants to participate need to connect only to the central server. This is what we call star topology. So here the central VPN router, any other VPN router has to connect to the central router and has to do this. And these subnets are said to be RIM subnetworks. This is the terminology used in the star VPN. Hybrid topology, combination of the previous mesh topology and the star topology. Sometimes they may also combine the bus topology. So different network topologies are added in this. So central core uses the mesh topology. Branch offices can connect it to a star topology. Like that, we can make a hybrid network topology. The benefits from the from strengths of each topology is like this: scalability, speed. So because in the mesh topology, reliability is one. In the star topology, scalability is one. Where in case of bus topology, very easy. So like that, one advantage, the advantage of individual topologies can be added in this. So here it is a hybrid VPN where you have the both the star and the mesh topology combined. So using the VPNs with the firewalls. I already told you that VPNs cannot be separated from the firewalls. You are supposed to use along with the firewalls, or either you need to place firewall first, then VPN routers and VPN, and side by side or maybe parallelly, something you are supposed to do with the firewalls. So VPNs do not reduce the need for the firewalls. Always use the firewalls as a part of VPN security design. Install VPN software on the firewall itself. The firewalls allows the outbound access to the internet. Firewalls prevent the inbound access from the internet. So VPN services encrypt the traffic to remote clients or networks. So in this way, it will help us, that the firewalls will help us in designing the VPNs. So install VPN software on the firewall itself. If you install it, VPN on the firewall itself, then the advantages are like this: control all network access security from one server itself, fewer computers to manage, use the same tool for VPN and firewall. But if single point of failure occurs, then the entire system will collapse. So must configure router routes carefully, otherwise it will be difficult. Otherwise it may choose a different path, and sometimes a split path will be happen, and thereby the entire VPN objective may be violated, maybe go waste. So internet access and the VPN traffic complete for resources on the server. So here is the example: VPN server on a firewall. So here internet and firewall will be placed. VPN or firewall combinations creates a single point of failure for all internet access. Something was gone wrong here, that's all. You will not get any internet connectivity here. So this is what the disadvantage. But if you use a VPN parallel to the firewall inside the DMZ, advantage is no need to modify the firewall settings to support VPN traffic. Configuration scale more easily, can deal with congested servers. Where in case of disadvantages are like this: VPN servers is connected directly to the internet. Then If VPN servers become compromised, then attacker will have direct access to the internal network. So cost of supporting a VPN increases with new servers. So here all internal clients communicate with the DMZ firewall 1 and are unaware of the firewall VPN server. So DMZ firewall 1 routes traffic to the appropriate next hopper. So direct because of it is because this VPN server uh, is the entry level. So if it was compromised, then as we have discussed here, uh, then it is very easy for the attacker to gain the direct access to the internal network because the VPN itself is the one who will perform the encapsulation of the original IP address. So whenever this is compromised, so everyone will come to know the what is the original IP packet and the IP header in that. So it is not a big task for the attacker to know about the internal information. Set up VPN servers behind the firewall connected to the internal network. So if you do this, advantages are like this: VPN servers is completely protected from the internet. Firewall is the only device controlling the access. VPN traffic restrictions are configured on the VPN servers. Disadvantages are like this: VPN traffic must travel through the firewall. So firewall should be in a position to scrutinize that much traffic. Okay, so that firewall should also be configured with the VPN headers. That means accepting of the VPN headers and all. So firewall must handle the VPN traffic also. So that means additional policies must be designed and should be incorporated. Firewalls must not know the what to do with the IP protocols other than the ICMP, TCP, and UDP. Then only you can design this VPN traffic as a policy in the firewall. So this is a disadvantage actually. So here is the example. All internal clients communicate with the DMZ firewall 1 and are unaware of the firewall VPN server. And this is the default gateway which is at the firewall level. And here is another firewall, and this is a VPN router, and here is also VPN router. So that is you are placing this before the DMZ. So DMZ is one that where the public resources are available. Here e-commerce server or FTP server, web server are the public resources. So before that you are going to place the firewall. So placing a firewall that is VPN server behind the firewall connected to the internal network. The advantages and disadvantages are like this. So we have seen so far three combinations: firewalls side by firewalls and VPNs, placing of firewalls behind the DMZ, VPNs behind the DMZ, VPN servers behind the firewall connected to the internal network. So adjusting the packet filtering rules for the VPNs to uh, to allow the protocol specific packets like PPTP is there, point to point tunnel protocol. So we need to write a policy in the firewall to accept such packets. So perimeter firewall packets like VPN sends or receives that must be included in the packet filtering. We have seen the packet filtering examples in the firewall settings. So you recall the same concepts here also. IP packet header fields used by the packet filtering: source address, destination address, and protocol identifier. So here PPTP packet filters, first widely supported VPN protocol, supports legacy authentication methods, does not require public key infrastructure. So PPTP use two protocols, TCP and GRE. So here is the PPTP packet file filtering rules to be set. Rule 1, just like how the general rules are going to set. And protocol ID 47. Here every VPN protocol that you use will be having a specific number that is to be used here. Destination port and action is allowed. So this is the way you go for setting of the PPTP packet filtering. Next is L2TP and IPsec filters. Need to set up rules for the permit to permit the IPsec traffic. IKE Internet Key Exchange uses the protocol ID as 171. As I told you just now, each and every protocol that is used in the for the encryption and other purposes in the VPN will be having an ID. So here IKE Internet Key Exchange will be having the protocol ID as 171. UDP port on the UDP port 500. So we need to allow this. So these rules must be placed in the firewall. And ESP uses the protocol ID as 50, and authentication header will use the protocol ID as 51. So L2TP, that is a link layer to tunnel protocol, where IPsec is used. So it will be having the protocol as IKE, ESPAH, and transport protocol, UDP protocol ID as 50, 51 will be allowed into the system or into the network. And next one is the auditing of the VPNs and VPN policies. Auditing need to be sure that organization have well-defined VPN policies. So access policies defined standard connection to the organizational network must be integrated with the security policy. So policies should be defined for different levels of restriction. So here auditing can be done via logging facility of the firewall. So whenever you use this VPN along with the firewall, so obviously the firewall should record the VPN activities. So the basic functionality of the firewall is for the filtering, and second one is for the proxying, and third one is for the logging. So this logging should be recorded and should be audited properly. So VPN endpoints are as vulnerable as internal network computers. So endpoints should also use the antivirus software and personal firewalls. Test each client that will connect to the LAN, so that we can detect the threats early. So you can standardize the VPN client for remote users. So example of third-party solutions are like this. All these are the proprietary ones. Verify everything is working according to your policies or not. To summarize this chapter, the business nature helps the determining of the virtual private network requirements. Based upon the organizational policies and security policies, VPN servers need to be deployed. Decide placement of VPN servers either before the firewall or along with the firewall, or within the DMZ or after the DMZ that you are supposed to design. And with respect to the parameters such as availability, reachability, reliability, the scalability concept, these are the properties you need to look for. And depending upon the number of employees who will operate, and whether you want site to site or site to client, based on that the design has to be done. Establishing a VPN domain is very, very important. And VPN configurations, either single entry point configuration or multiple entry point configuration will be done. It is always recommended to go for single entry point configuration, so that any traffic will has to pass through the single entry point only. So if you place an intrusion detection system there, then it is easy for you to monitor the traffic. And at the same time, VPNs need to be used along with the firewalls. So I hope you got how to design the virtual private network. That is, especially this VPN is to be designed based upon the security policies of the organization. And you may adopt the hardware VPNs, or maybe as VPN clients or VPN servers. And you are supposed to design this entire network setup with the VPNs along with the firewalls, DMZs, and intrusion detection.